we need to start talking and thinking about the AP exam that's coming up in May. From here on out, at least once a week, we'll either be looking at multiple choice questions that have been released from AP, or we'll be looking at actually grading a free response question and looking at that as well. But we're going to start today by looking at some of the released multiple choice questions that are specific to our current unit, which is like the second half of probability. On the AP exam, there are approximately 45 questions, multiple choice questions, that you have about an hour and a half to answer, which as you can do some calculations, it's approximately 2 minutes a question. So in theory, this should take you about 10 minutes to answer. Now, some of the questions are easier and some of the questions are more difficult. I get that. So it's just an average, right? So you'll spend some shorter amount of time on some and longer amount of time on others. This took me about 5 minutes to complete, if that, but I've been teaching it. I understand. But we need to make sure we understand. This first question, I think there's some notational issues we need to discuss. There's one on my desk. Help yourself. On the right behind Devin. We need to understand this notation, which I'm not sure that we have discussed yet. So we need to know what that means, okay? So we'll talk about that in a minute. But so we'll come back to this question if that's okay, because it's that's a notation that's an issue. But all of the other ones should be pretty self-explanatory. So have you guys had a chance to look at all these questions and try them? Do you need a couple more minutes, or talk to me? I know I yelled at you at the beginning of class, but you can talk to me now. Couple more minutes? Okay, that's fine. Let me go ahead, if you're still working, or let me just give you some notational, what does that mean, okay? If this has a comma between the probability of x equals 3, comma, the probability of y equals 4, it does mean the product of those two things. So it means that the probability of this times the probability of that, okay? So that's just notationally what that means. Okay, so that should help you answer question number 1. So let me give you about 5 more minutes to go ahead and finish these 5 multiple choice questions, all of which you should be able to do at this point, and then we'll go ahead and answer them. Okay? So on question number 1, since I went ahead and defined what this is saying, how do I find the probability that x equals 3? Go ahead. It's 1/6, because you know that in this probability distribution, all the probabilities should add to be 1. So I know that this right here is going to be 1/6, and I agree. Now, I can't do the same thing for the probability of over here because I have 2 missing values. Would you agree? However, I am told this information here, that the product, the 1/6, times the probability that I'm looking for, we'll call it the probability of y, so I'll just use y, is equal to 1/16. That's what that notation is saying, that those two products multiply to be 1/16. So if I multiply both sides by 6, the probability of y is going to be 6/16, which reduces to 3/8. So the answer to this question is simply going to be D. Yes, sir. What did I do wrong?
Because 3 is 4, it asks for 1, so it'd be 1/8.
Oh, look at you guys catching me and see what I did? Yeah, you're exactly right. So that's a probability of y, but that's not what it's asking. You're exactly right. This is 3/8, but what it's asking for is this sucker, isn't it? So you'd have to add all those up and subtract. So what is it?
1/8.
There, yeah. Yep, so it's going to be answer is A. Thank you. So, wrong your punctual. I'm correct myself here. You're exactly right. Good. Perfect. I agree. All right, let's go ahead and look at this next one. Now, how do I know by reading this question that it is a combining random variables question? It tells you right where. The sum, the sample of 2 observations. So we want to talk about the sum of 2 different things. So that should be kind of a red flag that is a combining random variable. So we need to newly define our variable. So we have 2 of the same types of things, much like the quiz. You had 4 dogs. So what is this going to be? How am I going to define the random variable? X plus x. So we're going to be looking for x plus x. So we're going to find a new mean and a new standard deviation. So what is the new expected value or the new mean going to be? 200. Just 100 plus 100. Perfect. What is the new standard? Well, let's do the variance first. The new variance is simply going to be, well, We get 5 squared plus 5 squared. And then so the standard deviation is simply going to be the square root of 50. Would you agree with that part? So once I've recognized that it's a combining random variable question, I'm going to define a new variable and find my new mean and standard deviation. Another key word that's given to us in this problem is normal, right here. Okay, so we know a little bit about normally distributed things. So I'm going to go ahead and draw. We know our new mean is 200. We're looking for the sum to be greater than 221, so I'm just going to put 221 on my picture. And I'm looking for greater than 221, so this is kind of the picture that I'm looking for. How do I take my... Do you figure out what you were doing? Okay. So how do I take my picture, the fact that I know normal, I have a new mean and a new standard deviation to get my answer? What would I do? Okay, and what would I type into my calculator? Let's write it out. Uh-huh. Uh-huh. Some big number. The new mean and the new standard deviation. And that's it. But we had to find our new mean and the standard deviation, and we had to recognize that it had one. Okay? And so when you do this, what did you get for your answer? You didn't say it loud? A, right. I agree. That's drawing the picture, right? Anyone get that on their own out of curiosity? Your calculator's not doing it right?
Our calculator's got 0, so
I got 0, and that's wrong.
Okay, if that's the case, then obviously you have to go into the mode and, No, you go to your mode, and it has to do with the way your calculator is rounding. You should have it on, well, you do have it on float. Wonder why it went straight to 0? Mine didn't. So let me just plug it in like I plugged it in. I plugged it in on Erica's calculator. That's because I used your calculator.
Oh.
Remember I borrowed your calculator? Silly girl. Okay, yeah. So normal CDF would be 221 to E99. And then my new mean is 200. My new mean is the square root of 50. Paste. I didn't get a 0. I wonder why. It went straight to 0, nothing else. But I want to figure out why yours did. Let me think about that, okay? Because that should not. It's a setting issue, and I'm just trying to figure out why it's what. Did yours do that? Try to reset your memory. That's a good idea. But there's some wonderful. I'm just trying to figure out what the setting is that's making it do that. Well, I mean, the float's the only thing I could think of. That has nothing to do with it. I don't know. All right, well, I don't want to spend too much time on it, but let me think about it, okay, and see if I can figure out a reason why it would round that much, because it definitely shouldn't. Because that would be a problem on the exam, for sure, because there's too many, and you wouldn't want to pick the smallest one, because you don't know that this might, I don't know. Anyway. All right, question 3. Sorry again that the paper got filed up when I copied it. Just turn it over. If you look at question number 3, we're talking about, well, you read the question and tell me how you knew what strategy to use. What strategy did you use here? I see Sean drew it, so Sean, tell me what you did. Right, and how did you know to do that? Because that's exactly right. That is the process. How did you know to do that? There's more than one thing going on. I agree. You can either have forbidden material in your suitcase or not, and you can trigger an alarm or not. So when you have more than one thing going on, that to me screams tree diagram, and I agree. So let's just draw one real quick. So you either have forbidden material or you don't. And then you either trigger an alarm or you do not. Okay, and so we're just going to fill in our tree diagram with the numbers. And so the numbers we have here, it does say 97% of the bags that contain forbidden material trigger an alarm. So that means that it contains forbidden and the alarm was gone. So here we go. And then this would be 0.07 because you know that the branches of the tree should add to be 1.
97.
What did I say? I said 97 and I wrote 93. All right, 97.03, and that is why, no, I have that on my paper. Okay, great. Then it says 15% of the bags that do not contain forbidden material, so I'm on the lower branch now here, may also trigger an alarm. So I have that, and then I have 0.85 down here. And then it says 1 out of every 1,000 bags actually contain forbidden material. So we have 1,000, which is that, correct? And so that would be 0.999, and they add to be 1. Any questions so far? So we have to ask ourselves, what is the question asking? What is the probability that a bag that triggers the alarm, so it's triggered the alarm, so given that it's triggered the alarm, what's the probability that it actually contains forbidden material? So given that it's triggered the alarm, what's the probability that it contains forbidden material? So this is what we're looking at. Do you agree? Okay. So that's going to be the probability of forbidden and alarm divided by the probability of alarm. Now, probability of forbidden and alarm is this when I multiply them across. Do you agree? 0.001 times 0.97. So 0.001 times 0.97 divided by, well, trigger an alarm is either here or it's here. So we have to add those together to be the alarm. So that's going to be whatever number that is. I think I got 0.00097 plus whatever this probability is, and I got 14985. What did I do? So 0.999 times 0.15, 0.14985. Okay? So 0.14985. And then when I go ahead and do that calculation, I got close to this answer. Double check me though. Did you? Sean, were you able to use your tree diagram that way? Yeah, you got it, because there's two different possibilities, right? That's definitely a question we have done before, or at least one like it. It's just remembering what to do. Are there any questions on that one? That was a total review problem, not combining random variables, nothing like that.
Yeah.
Is that what you got too? Same thing? Okay. How about number 4? What would you do? What strategy would you entail to solve this problem? Is this a tree diagram problem? I don't think so. What is it though? What did you do? Did you get to it? What'd you do? I drew a probability distribution, like a little table. I don't know. Did y'all do that? That's what I did. Tanner says, yep, that's what I did. I said, okay, what are the outcomes? And what's the probability of those outcomes? Did you guys do that? Well, if you did it, then tell me. That's okay. It's just a way to organize it, right? That's all. So what are the outcomes? Well, I can win or gain how many points? 20 points. And what's the probability of me getting 20 points? Because only when a 6 shows up, so 1/6 of a chance. And then the other outcome would be losing 3 points, so -3, and that would be all the other time, so that would be 5/6 of the time. All right, and that's all the outcomes. They add up to 1. We're good. We're going to roll this sucker to, 100 times? And we're going to figure out what our expected point value is going to be. So how would you do it? How do I find, when it says expected, that's the same thing as the mean. So we have 20 times 1/6 plus -3 times 5/6, or -3 times 5/6. And then you would take that expected value of one roll and just multiply it by 100 to get your real rolls. And so that I got C, yeah, 83 points. Is that what you guys got?
Yeah.
Okay. Yay! That was a pretty short, sweet one. Hopefully that's I got that one right problem. Okay. Now the last one I think is pretty tough. You tell me. You think you got it? You got it? Okay. Anybody solve it all the way? What'd you get, Daniel, as your answer? You got C? What'd you get, Lindsay? C? What'd you get? B? So did I. I have your bad self, Evie. I got E. Did you get E, Jordan? He's like, yeah, I got that too. Did he really, Devin? Is he just? Okay. All right. I'm just saying, because as Miss Demby would say, you're suspect. All right. Let's see why the answer is E, because it is.
Oh, I just realized what I did.
Okay. Let's talk about it. So, first of all, when I read and these questions, and God love AP, they're challenging us to be mindful students and contextual readers, and I love that, but every problem is like a page long. It bothers me, but that's okay. We're going to continue to read it. When you're reading this problem, it's a long problem for a multiple choice, I think, personal opinion. They can be longer too, but whatever. I know, right? That's kind of where I'm bothered. It takes 2 minutes just to read it sometimes. I agree. So when I read this, how do I know what to do? What strategy am I doing? How do I even start this? I know I have to redefine my variable. Very good, okay? Now, it's probably because this is the unit we're in that we are thinking of this, but what are some clues as I'm reading this question that it is a combining random variables question? I'm given a couple of different mean and standard deviations. That's definitely a clue. What else? What am I doing what am I trying to find? Of what? Of a box and 10 bars. So I'm kind of I'm trying to find a new thing, right? So I'm going to define my new variable. Let's let the bars be X. I would say B for bars, but box begins with a B too. So let's let bars be the X and Y would be the box. Is that okay with you? They're different things that have different variables. So what's my newly defined random variable going to be? 10x plus y. Well, hang on a minute. I don't think it's 10. I think I'm wrong. I think it's x plus 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 x. I just realized that. It's 10 of them, right? So I think that's wrong. So I think it's that. Do you agree? I think the answer is not E. Okay? Look, I love when we go through this and we work them together. So I agree with this. This is correct. So I've got to find the new what? Standard deviation. Okay? So how do I do that? Well, I'm going to work with the variance. The variance of this, I'm just going to write the new. Okay, is that okay with you? Variance of the new? The variance of the new is going to be, well, what is x? The variance is, so we have the variance here. Our standard deviation is 16. So be 4 squared, right? So we have 4 squared. How many times? 10 times. There's 10 of them, right? Plus 8 squared. You with me on that? And so the standard deviation would simply just be the square root of that. Do you agree with that part? Okay. So let's figure out what number that would be. Maybe that's why you guys got it right and I got it wrong. So the square root of 4 squared times 10 plus 8 squared. So 14.9, oh wait, hang on, it didn't write it that way, did it? It gave it to you with the radical, didn't it? Oh, sugar. Is that right now? Okay. So the square root of 224, is that one of the answers? Okay, so the answer was C. Okay, good. Yeah, so you were right. I was wrong. Thank you, Daniel. Excellent. Do you have a question, Sweet Pea?
Mm-hmm.
Go ahead.
You don't have the constants.
Those aren't constants because it's 10 bars. A constant would be if I added
Y plus 5.
like y plus 5 is a constant. So x is not a constant. X is an actual variable. It has its own mean and standard deviation. Totally stealing pencils. I'm sorry? Who got that one, by the way? Okay, keep your hands up, because y'all did great if you got that. So keep your hands up. Hang on. Stop the recording. All right, so the answer was C. So again, once a week we're going to start practicing this and look at some this week was multiple choice week. Next week is going to be an FRQ. Okay, it means free response questions. So we'll look at one of those next week. Go ahead and let's we're going to start talking about our final unit before we get to our last section, our last topic, what's called inference. This is going to be our last little mini unit. And it has everything to do with these NFL popsicle sticks that we've done all year long. Okay? So let's take at least 10 minutes and kind of start the discussion, and then we'll finish it next class. Okay? So in our box that we've kind of haven't really been diligent about doing it every day, but we've been pretty good. In this box, a group of 15 sticks that we kind of were doing on this last chart here. If I took a group of 15, what is that called? Let me just pretend like this is a group of 15. What is this called? Okay, so it's called a sample. We know that. Good. And all of the sticks represent okay, that's kind of important to understand the difference. Okay. If our group of sticks had the following salaries in hundreds of thousands, we can find the mean and standard deviation of this sample. You were finding the mean over and over, right? And since it's a sample, we call these mean and standard deviations what? Statistics. They are called statistics. We use these as our symbols, right? X bar and SX, we know that. And that would be your statistics. Now, when we talk about the mean and the standard deviation of the entire population, what is it called? They're called parameters, okay? And those are different things. Sample statistics, population parameters. So, the real question we have is what do the samples that we've been taking over and over really tell us about the population? Okay? We would like to think that because it's a random sample, I mixed the sticks up, right? Every time you guys came in, you might not have seen me do that, but trust me, I did. We would hope that that sample would be representative. Now, poor Kyle's little guy over here, is that very representative? I don't think so. But what did we say? That was, we found the mean, didn't we? We didn't find the sample. That little dot represents an average, does it not? Okay. So in a large population, now this is not very large. This is a very small, confined population, but there are large populations. Can you think of one, for example, that we would never figure out the mean and standard deviation of? The human population, sure. Like the age of us, or the height of us, or the weight of us, or whatever, sure. Fish, you can't ever catch all the fish in the sea, sure. Give me something else. Some other population we would never be able to calculate, an average. The height of all the trees in the world. I mean, something that's just not possible. So we have to use samples to kind of represent what we're trying to do. So we know that these sample statistics, we know what those are. So, dun-dun-dun. All right, we'll come back to that. All right, what if we, I'm sorry? We already know this stuff, okay? We're getting ready to start the new stuff. So if I took a sample, okay, pretend I took a sample, here it is, okay, would it represent the population if it's random? Possibly. We hope it does, right? Okay. What if would it have the same mean and standard deviation as the sample I did earlier? No, most definitely probably wouldn't. I shouldn't say definitely, but it's very unlikely that it would. And isn't that because with every sample there's variability amongst them? There's one sample varies from the other. Okay. So a sampling model is a model of all of the possible samples. Okay? So if I were to think about trying to look at the salaries, and I looked at all the possible combinations of 15 sticks, well, we'd be here a while, first of all, wouldn't we? But you can kind of imagine that's kind of filling in, that's what I mean by sampling model, okay? All the possible combinations of each of the samples. Now, here is, we even have time for the moment. We have something called the central limit theorem in statistics. And I want you to take a look around the room for a minute. We're going to go counterclockwise. I want you to look behind Tanner, and I want you to look at the population and the shape of the population of those sticks. Give me your shape. What is the shape? What do you think it is? And I would even use a stronger word. I'd say heavily skewed right, wouldn't you? Very skewed right. Okay, kind of like the guy who caught the interception, the rookie dude for the Patriots. He's over there on the far left, right? Tom Brady gave him a truck. Hallelujah. You know, that was awesome. I'm so proud of him. That was great. But, you know, Tom Brady's over here, you know, I don't know, over by the calculators, right? He makes way too much money. So anyway, very skewed right. Let's move behind Judith now, behind Judith. And what do you see that shape to be? Skewed right, but wouldn't you say less skewed right? Okay. And let's come over here. Now, we're going to pretend like Kyle doesn't exist over here. I hate to say that, Kyle, because if you're listening, you definitely exist. But we're afraid of your 17.1 million guy. I don't think that's right. Anyway, we're over here. And what do you think this is? Still skewed right, wouldn't you agree? But it's becoming more what? Becoming more mound shape, wouldn't you agree? So that has to do with the sample size. The larger sample, now this is something I would not have made you do. Thank you, you're welcome. But the closer our sample size gets to, the magical number is about 30, okay? Now, that number, sometimes some books call it to be 40, but we're going to use 30, okay? So the magical number, if I take a sample size of 30, and I do it over and over and over again, and I populate my graph, but, you know, taking 30 sticks and averaging them would take a long time, and I wasn't going to do that to you. But if I did that and I made another graph over here of sample size 30, guess what would have happened? The shape would be normal. And we could use a normal probability model to estimate probabilities of the means. Now, we have to be careful. These little dots on these two graphs, not the one above Tanner, but these two above Judith and over here to my right, your left, are actual means, aren't they? Isn't every dot an average? So what the central limit theorem says, when you have a sampling distribution for a mean, an average, it becomes more normal. Well, that was back here, sorry. It becomes more normal, and we can actually use a normal model to estimate probabilities. Okay? Yes. I think I say it back here, actually. As we draw more and more samples, the sampling distribution becomes more normal. And not only that, but it becomes centered around the actual population mean. So, in other words, this is not the pretty graph, but could we figure out where the middle of this would be? So we could estimate the average, these are all means now, but the middle of the average of the means, the average of the averages, ooh, that's kind of weird to say, isn't it? Because these are all averages, each dot's an average. So the average of the averages becomes the average of the population. That's kind of strange. So I would estimate it to be about, what, 1 million maybe, according to this graph? Okay. A little harder to see on the population, but that's kind of an important concept, okay? And again, the sample size, the magic number, what did I say it was? So we're going to say it needs to be at least 30, greater than or equal to 30, and that's the magic number. We didn't get to it. You're welcome. Okay, I don't want you to have to do that. But that's really what we're talking about. So here are the two formulas. Tanner's already packing up, so he's missing out on writing these down. But here are the two formulas that you're going to need to know. Okay? When we're talking about the CLT, not a BLT, but a CLT, the central limit theorem. Remember how on the problem before, when we did the multiple choice questions, they had normal model in there, but we had to find a new mean and a new standard deviation? Remember when we combined random variables, we found those first? These are the formulas to find your new mean and standard deviation. Okay? So, we'll talk more about this. Your homework is going to be to read chapter 18 and to do the just checking. Okay? That's going to be your homework. Did you already have to do chapter 18? Or what was it? I'll tell you in a minute. So read chapter 18 and do the just checking, please. I'll give it back. And it should be in your note. It should be in there too.